Hey guys, my apologies. I should have created this video on Monday. It is now Thursday, so my bad, guys. But let's go ahead and talk about this exam and see if the questions were fair and legit. So here we go. Question number 1. It says describe how the graph of g of x equals 5x plus 4 with a square on it minus 2 is obtained from this function. That's your parent function there, guys. Y equals x squared. That is just that graph. So as you know, this x plus 4 makes your f of x, makes this graph move 4 to the left. So 4 left. This 5 is a vertical stretch by a factor of 5. And that minus 2 is a vertical shift down 2. Vertical shift 2 down. So that's what we're going to look for, guys. All of them have vertical stretch by a factor of 5, so it's not like we can delete any of them. Vertical shift 4 units upward, out. Vertical shift 2 units downward, okay, maybe. Yeah. Horizontal shift 4 units to the right, nope. Vertical shift 4 units downward, out. Vertical shift 2 units upward, out. Vertical shift 2 units downward, horizontal shift 4 units to the left. There it is. Okay, next question. They want the difference quotient. I already got f of x. You need an f of x plus h. So I'm going to write f of x plus h equals parenthesis x plus h, close it, squared, plus 2 parenthesis x plus h, close it, minus 4. And then we're just going to expand, guys. X times x is x squared. X times h is x h. You're going to have 2 of them. H times h is h squared. Plus 2x plus 2h minus 4. Let's see, is there anything that combines? I don't see anything that combines. So now we're going to go ahead and do the difference quotient. So here we go. I'm going to write f of x plus h minus f of x all over h. Oh, that looks like lambda there. Equals x squared plus 2xh plus h squared plus 2x plus 2h minus 4 minus this expression here. So minus x squared plus 2x minus 4, and all that is under h. Now when you distribute this negative here, guys, we're going to have the following expressions. We're going to have a negative x squared or minus x squared minus 2x plus 4. So having said that, let's zero out some stuff. That's a positive x squared with a negative x squared. I have a positive 2x with a negative 2x, negative 4 with a positive 4. So we are done, almost done. Every single term that you have left has an h on it. Notice that. So I'm going to factor out an h, and you're going to have 2x plus h plus 2 all over h. The h's cancel out, and there's my expression. Hopefully that was cool, guys. Question 3, it says find the domain of the following function. Well, the top part is just a rational function. It's just a linear line here. So this is a rational function. X plus 5 has all real numbers, so we're not really focused on that. I'm focusing on the bottom, guys. You can't divide by 0. So what makes this expression 0 are going to go x squared minus 4 equals 0. Remember, it cannot be 0. So x squared equals 4, square root. X cannot equal positive and negative 2. You could also have done the difference of squares. It's the same thing, no big deal. If this were free response, you can say you can say all real numbers but positive and negative 2. Excuse me, guys. But since I have multiple choice, they wrote them in interval notations. You're going to go negative infinity. You read it left to right, right? Negative infinity all the way. Which one do you hit first? The negative 2. And then union from negative 2 all the way to 2. And then union from 2 all the way to infinity. So I think it is this one right here. All right, let's go to the next one, guys. So this one wants the domain, and notice that I do have a radical on the top. Now, remember from your Algebra 1 or Algebra 2 class for parent functions, the domain of a square root function is all numbers larger than or equal to 0. That's because in the expression in here, that's the parent function, right? Y equals square root of x. The expression x plus 1 itself cannot be smaller than 0 because you can't have a negative number inside the square root. I mean, you can, but that negative number is going to be imaginary. And we're not talking about, we're not in the complex plane. We're not talking about poles or anything like that. So what we're going to do, guys, you set the expression x plus 1 greater than or equal to 0. And you can equal 0. So let's see, x is greater than or equal to negative 1. So there it is. Now, remember, you can't divide by 0, right? So x cannot equal 6. If this were free response, this would be the answer, and that's perfectly acceptable. But they wrote them in interval notation. So bracket negative 1 all the way till you hit the 6. You cannot equal 6. So there it is, parenthesis, union, parenthesis 6 all the way to infinity. And we look for that answer, guys. All right, let's go to the next one. So this one's pretty straightforward. Remember, f of happy face is nothing more than happy face squared plus 6 times happy face plus 1. So pretty much, if you whatever expression you have, that's where you're going to be substituted in for x. So sometimes it helps, guys, to write parentheses like so. So there it is. So I'm just going to rewrite the same thing. Parenthesis x minus 4, close it, squared, plus 6 parenthesis x minus 4, close it, plus 1. And then we're just going to expand it, guys. So x times x is x squared. X times negative 4 is negative 4x, but you're going to have 2 of those, so minus 8x. Chavez, what are you talking about? Negative 4 times negative 4 is 16. I didn't even answer your question, which you didn't even ask, right? I'm asking the question there. So what I'm talking about, guys, is that you have 2 of these. X minus 4 times x minus 4. So x times x is x squared. X times negative 4 is negative 4x. You're going to have another one right there. And then negative 4 times negative 4. Hey, look, it looks like a happy face if you really look at it. So there it is. That's how you expand that, guys. And then distribute that 6 there. Plus 6x minus 24 plus 1. And then you just combine like terms. X squared, negative 8x plus 6x. Well, that's going to be a negative 2x. And then I got a 16, and I guess technically that's a negative 23 there. So what's that? Minus 7, because the 23 is larger. So there it is. X squared minus 2x minus 7. Hopefully I didn't make any mistakes. Let's go to the next one. Suppose that f of x is an even function. So that means symmetric about the y-axis. And the point negative 2, 4 is a point on the graph of f. Which of the given points is also on the graph of f of x? Well, negative 2, 4 is right there, and this is just an approximate. So if I'm symmetric about the y-axis, that means I'm going to be here at 2, 4. Yay. All right, guys, let's go to the next one. Suppose the point 4, 2 lies on the graph of the function f of x. If the function is transformed as 2 f of x plus 5 plus 3, which of the following will be the coordinates of 4, 2 under this transformation? Okay, so first, I'm going to move 5 left. That's what that s plus 5 does, guys. 5 left. So if I move 5 left, I'm going to be a negative 1. So out, out, maybe, out. Maybe f, right? All right, so next, what's going to happen? Well, this vertical stretch messes with the y value. So you're going to take the y value, which is currently 2, and I'm going to stretch it by 2. So 2 times 2. And then that plus 3 also messes with the y value. It moves it up 3 units. Remember, that's a vertical shift up 3. So 2 times 2 is 4, and then I'm going to add 3 to it, guys. So 4 plus 3, 4, 5, 6, 7. So I'm going to be at negative 1, 7. So there it is, and I look for it, and we're done. If I'm going too fast, guys, feel free to please pause it. I'm trying to fit in this video here because I have a Zoom meeting in a little bit at 6:30. So hopefully I can get that in here before my Zoom meeting here. This is a composite function, guys. Solve for f of 5 first. I think by now most of you guys are getting pretty good at this. 5 minus 4, that's just a 1. And then just go g of 1, because that's what that is, right? F of 5 is 1, and you have the g on the outside there. So g of 1 is 4 times 1 minus 2 times 1 squared. So 4 minus 2, 2. Awesome. All right, guys, the next one. Given the table to the right, what is the value? So this means inverse. So what does that mean? That means that negative 6 is a y value on f of x. So really, it's like saying this: f of what is 6? Well, let's see what that question mark is. Right here. See? Oh, and I said 6, and it should be negative, right? I keep the negative sign, guys. I don't know why I dropped it. That was my bad. It is that one. This one right here. So negative 6 is a y value on f of x. I wrote it here, but I didn't write it here. So that's negative 6. There it is. So what's that question mark? That's f of negative 4. So f of negative 4 equals negative 6. So that means inverse of negative 6 must equal negative 4. This is an x value on f of x. X value on f of x. And that is your y value on f of x. In case you're wondering, Chavez, why is that? Because remember, for you to be an inverse, guys, it must reflect across the line y equals x. So that's part of the property. You must reflect across this line. So if I have a point a comma b, and I reflect across that line, then I'm right here at b comma a. So Chavez, what are you trying to say? If I have a point f of a comma b, and I find the inverse of it, I in v, then it's going to turn to f of b. Look, notice that I put the inverse notation. So let me put the inverse notation. The inverse notation, b equals a. So maybe put this in your notebook or your notes somewhere. F of a equals b, inverse, f negative 1 of b equals a. So that's pretty much, hopefully if you understand that, guys, you won't get any of these type of questions wrong. Find the inverse, again, just like we just talked about right now, y equals x. So that means we can just interchange the x and y and solve for x, or solve for y, sorry. So I'm going to go x equals square root of 4 minus 7x, and I'm going to square both sides. So when I do that, you're going to have x squared equals 4 minus 7x, and then I'm going to move the 4 to the other side. So x squared minus 4 equals negative 7y. Sorry guys, I'm going really fast here. I said that I switched the x and the y, and I didn't show this is a y value, so I'm trying to slow down here. I switched the x and the y, right? So this is a y value. So there we go. I hope we're okay right now. What I'm trying to do is get the y by itself. I'm going to divide by negative 7. So here's what I have. I'm going to call it inverse. So f of negative 1 to the f to the power negative 1, that means inverse, equals, and negative divided by negative is a positive, so I'm going to write that part first, minus x squared over 7. So let's see, out, maybe. So then I have these x values here. So what are they going to be? Well, my range of original is domain of inverse. The range of the original is a domain of the inverse. So what that means, guys, is since my range for this function, remember, there is a square root function, guys. If you remember, your square root function x looks like this, a parent function. And the range is all values larger than or equal to 0, right? So it's the same thing here. I don't see any vertical shift on the outside. I don't have a plus or minus anything. There's no plus or minus any number. So that means that my range is all numbers greater than or equal to 0. So if that's my range, then that means my domain of the inverse must be x is greater than or equal to 0. So it has to be that one. So there it is, guys. We got it. All right, next one. These are points on the inverse function, guys. So I don't want the inverse. It says to find f. So that means 1, 2, and negative 3, negative 7. These points are on f, or on f of x. So let's find my slope. My slope, negative 7 minus 2 over negative 3 minus 1. 7, 8, 9, negative 9 over negative 4. So I see a positive 9/4. That's the only one I see with a positive 9/4. So let's check. Let's see if it really is. So y minus 2, I'm using this point, equals 9/4 x minus 1. Distribute. Y minus 2 equals 9/4 x minus 9/4 at 2. Now remember, 2 is equivalent to 8 over 4. So negative 9 plus 8 is negative 1. So I'm going to have a function of 9/4 x minus 1/4. And there it is, guys. Okay. Find the linear function that satisfies negative 3, negative 1, and has a graph that is perpendicular to the line. So here's the line that I'm perpendicular with. So first find this slope. Find this slope. So here we go. 5y equals 50x minus 10. Divide by 5, divide by 5, divide by 5. Y equals 10x minus 2. We don't really care about that minus 2, guys. This is what we care about. If this is my slope and I want to be perpendicular to this specific line, which is this one, my new slope must be opposite reciprocal. Negative 1/10. So out, 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 maybe. It's between those two. I need to go through this point. That point is negative 3, negative 1. So here we go. I'm using my point slope formula. Y minus a negative 1. So y plus 1 equals a negative 1/10 x minus a negative 3. So x plus 3. Let's solve, guys. Y plus 1 equals a negative 1/10 x minus 3/10. I'm going to subtract 1. So remember, 1 is the same thing if I want to use the denominator of 10 as 10 over 10. So if I subtract negative 3 minus 10, that's negative 13. So my function, f of x, is equal to negative 1/10 x minus 13 over 10. Yay. All right. Give the coordinates of the x. I don't know if you guys can hear, but they're mowing the lawn. I can hear someone mowing the lawn. Anyways, give the coordinates of the x-intercept for the graph of this function. So I want the x-intercept. So remember, that's where this function equals 0. So I'm going to go ahead and equal that to 0. X squared minus 6x plus 8 over x squared minus 10x plus 16. So it helps to factor it out in case we got some factors that are going to cancel out, guys. So two numbers that multiply give you a positive 8 but add up to a negative 6. I believe that's 4 and 2. Negative 4, negative 2, right? So x minus 4, x minus 2. And on the bottom, same thing. Two numbers that multiply give you a positive 16 but add up to a negative 10. And I believe that's 8 and 2. X minus 8, x minus 2. So there it is, and I can see that the x minus 2's are going to cancel. So the only way you can get a 0, guys, if the expression x minus 4 is 0. That's the only way. 0 divided by anything is 0. So x has to equal 4. And that's it. On number 14, it says give the vertical asymptote for this graph. Well, it's the same graph, guys. It's that. The only thing that I have left in the denominator is this x minus 8. Remember that you can't divide by 0, so you get your vertical asymptotes from the denominator. So I'm going to write x minus 8 equals 0, and you're going to get 8. So this is my vertical asymptote. Alright, we're almost done, guys. It looks like this is the last one here, so yay, we finished. The graph of this function has a horizontal asymptote. Okay, so they're telling you it has a horizontal asymptote. If the graph crosses this asymptote, give the x-coordinate of the intersection. Well, okay, now they're kind of going back on it, right, because it says the word if. Otherwise, state that the graph does not cross the asymptote. So it does cross, guys, but remember, you're not using a calculator. So the first thing you got to do is recognize what the horizontal asymptote is, and that's just end behavior. So hopefully you've done that in previous math courses. So the end behavior is just y equals 2. So that's my horizontal asymptote. So I'm going to go 2 equals, and I'm going to write 2x squared plus x plus 3 over x squared plus 5x minus 10. So now you can just write like 2 over 1, and then you can just use that feature like cross multiply that you've been doing since junior high. So we're going to write 2x squared plus x plus 3 equals, and I'm multiplying that by that, right? So equals 2x squared plus 10x minus 20. So here we go. The 2x squares cancel out. I'm going to move the x's to the right. Minus x, and I'm going to go plus 20 plus 20. So 23 equals 9x. And then divide by 9. So there it is. X equals 23 over 9. Yay. All right, guys. I hope you guys understood that. Hopefully you answered this question there. And I did read everyone's. So actually, I know who replied and who didn't. So I read all of them. And I will adjust, guys. Hopefully you guys are enjoying your math life. and let's continue and keep pushing forward, guys. I hope you're doing all right. I hope that you are safe and in a good place, and I'll see you guys when I see you guys. All right, talk to you guys later. Bye.